Hello Math 1093, this is Dr. P with Uncaging the Beast. And the beast, of course, in this video is this rather unpleasant looking equation I put here for us to solve. Okay, so we want to find all real solutions t that satisfy this equation. 3 square root of 2, whoever came up with this, 3 square root of 2 times cosine of quantity 2t plus pi over 2 minus 4 equals negative 7. Okay, so we're gonna work through this step by step. The first thing we're gonna do is we're gonna write this equation in a form that is a little bit more amenable to analysis here, and that is we're going to rewrite this equation so that we isolate this piece. We want to isolate this trig function here as much as we can. All right, so the way we're going to do that is do all the standard stuff first. Like I have this subtraction of 4 on the left side. Let's just get rid of that and move that over to the right side. Alright, so let's add 4 to both sides, and that's going to give me 3 root 2 cosine of 2t plus pi over 2 minus 4 plus 4 equals negative 7 plus 4. So that's going to give me 3 root 2 cosine of 2t plus pi over 2 equals negative 7 plus 4, which is negative 3. Okay, that's a good first step. Let's clean things up a little bit. Now again, my goal is to get this part by itself, this cosine of 2t plus pi over 2. So my next step is going to be to divide both sides by 3 square root of 2. So I'm going to show that in a separate step here, and I urge you to do the same. Sometimes students try to do several steps at once, like they'll show the division in this step as well. I actually encourage you to spread the steps out a bit. So rewrite this, and then show the division by 3 square root of 2 in order to isolate the cosine. Okay, so that's going to give me cosine of 2t plus pi over 2 equal to, and I can cancel those factors of 3 out because 3 is a factor of both the numerator and the denominator. I get negative 1 over the square root of 2. And that should be recognizable there. Gee, maybe somebody who put this, maybe the person who put this equation together was thinking, hey, maybe I should get a nice value like negative 1 over square root of 2 here. That'll help things. So look at this equation now. I've now simplified the original equation to this one. And now all I need to do, so I've reduced this problem. I've reduced the problem to finding all real numbers t such that the cosine of 2t plus pi over 2 is equal to negative 1 over the square root of 2. Okay, so just for reference, I'm going to remind myself, where would I expect to find angles whose cosine is negative 1 over the square root of 2? So I'm going to draw my circle picture. Now you may eventually be able to do this without drawing circles, but I think I would like to do this every single time. It just helps me to visualize things. So where can I expect to find angles whose cosine is negative 1 over the square root of 2? Okay, well if I want the cosine to be some negative value, then that means I need my x-coordinate to be negative. So I'm going to be in one of these two quadrants here, either the second or the third. So one of those angles is going to take me exactly due northwest. That angle is going to be, what is that? That's, well, pi would be an entire half rotation, so this would be 3/4 of pi. 3/4 of pi, also known as 3 pi over 4. The other angle between 0 and 2 pi that would do it would be this one here. These 2 points, by the way, should be at the same x-coordinate. It doesn't look like they are, but they're meant to be. So this other angle here is a half rotation plus an additional pi over 4. So that's 5/4 of pi, or 5 pi over 4. Okay, so I have those 2 angles, but keep in mind those are not the only 2 angles in the world whose cosine is negative 1 over square root of 2. Those angles would include these angles, but they also include these angles plus any number of full rotations. Okay, so let me just summarize this finding here, because this is actually going to be very important for the next step of this process. So when I get to this point, I want to ask myself, okay, which angles have cosine equal to negative 1 over square root of 2? Because those are the things that are going to be the values that 2t plus pi over 2 could be equal to. All right, so what this tells me is that 2t plus pi over 2 could be equal to 3 pi over 4 plus any number of full rotations, where k is an integer, or 2t plus pi over 2 is going to equal 5 pi over 4 plus any number of full rotations, again k an integer. Okay, so now I've reduced this task. Now that I've reduced the task to figuring out what 2t plus pi over 2 could equal to, and I've found actual concrete values that 2t plus pi over 2 could be equal to. So these are the values which, if I take the cosine of them, I will get negative 1 over the square root of 2. So now I've reduced this task to solving a linear equation in t. I just need to solve for t on each of these. Okay, so let's do that now. On the left equation, if this left one is true, then I get 2t equal to 3 pi over 4 minus pi over 2 plus 2 pi times some integer. So let's simplify that a bit. 2t is equal to, let's see, that's 3/4 of pi minus 1/2 of pi. That is 1/4 of pi. That's pi over 4 plus 2 pi k. And then t is going to equal half of that. Half of pi over 4 plus 2 pi times k. That's going to equal pi over 8 plus half of 2 pi k is just pi times k. So that's one possibility there. The other possibility is that 2t is equal to 5 pi over 4 minus pi over 2 plus 2 pi k. So again, I'm taking this equation here and I'm subtracting pi over 2 from both sides. All right, so that means 2t could be equal to, let's see, what is 5/4 minus 1/2? That I think is 3/4 plus 2 pi k. And then multiplying by 1/2, I get t equals 1/2 of all of that, 3 pi over 4 plus 2 pi k, which comes out to 3 pi over 8 plus pi k. All right, so that's my other possibility here. Okay, so again, just to summarize what happened here, I got to this point where I knew exactly what I needed my cosine to be, and I thought, okay, well, what things could go here? What angle measures, when I take the cosine of them, give me negative 1 over root 2? I worked that out using this picture here. Using this picture, I saw that those angles, that is this value of 2t plus pi over 2, needs to be either 3 pi over 4 or 5 pi over 4, or one of those angles with a full rotation added to it, or some number of full rotations. That's what gave me these expressions here. And then I solved each of these equations for t. So I said 2t plus pi over 2 has to equal one of these amounts. And then I solved each resulting equation for t. Okay, now I'd be remiss here if I didn't do a little bit of checking to make sure these results actually make sense. So the equation I was trying to solve was what? I was trying to solve the equation cosine of, wait, what was it? It was like 3 root 2. Bring on all the bells and whistles here. 3 root 2 cosine of 2t plus pi over 2. What was it? Minus 7 or minus 4 equals negative 7. I'm just trying to remember what I wrote earlier. That was the original equation. So I should do a little sanity check to make sure that at least some of these solutions work. I could do that by actually substituting in these general expressions here, but instead I'm just going to demonstrate by picking one example value from each of these and checking that that works, just as a sanity check. All right, so what if I take this expression here and I say, well, one possible value of that would be pi over 8 plus just pi times 1. That would be 9 pi over 8. So what happens if I substitute that in? I get 3 root 2 cosine of 2 times 9 pi over 8, just substituting in t there, plus pi over 2, minus 4 equals negative 7. I want to check whether that's true, so I'm going to put a question mark there. All right, so then that amounts to 3 root 2 times the cosine, and then 2 times 9 pi over 8, that's 9 pi over 4. If I add pi over 2 to that, I'm going to get 11 pi over 4. And I want to know whether that minus 4 is equal to negative 7. Well, 11 pi over 4 on the unit circle, if I count out quarters of rotations, this is 4/4 of pi, and this is another 4/4, that's 8/4, and then I get 9, 10, 11. 11 pi over 4 takes me somewhere up here, and that should look really familiar actually. the cosine of that is negative 1 over root 2. If I subtract 4 from that, I should get negative 7. Let's just check. 3 root 2 times negative 1 over root 2, that's negative 3, minus 4 is indeed equal to negative 7. The equation checks out, and now I know that at least that one value, that 9 pi over 8, is a solution. And I can actually test this full set of values by substituting all of those in for t and simplifying that expression. Okay, I'm already 10 minutes into this, so I'm not going to do one of these manually, at least not in the video, but you should check this yourself. Check 3 pi over 8, or you could check 3 pi over 8 plus some multiple of pi, like 11 pi over 8, or maybe even 19 pi over 8, and see that that also satisfies the equation. That's a good thing to do every time you work with one of these, is actually verify that your that your solutions do what they're supposed to do, and that is make this equation a true numerical statement. All right, so anyway, that's the process for solving one of these. Try and isolate that one trig function, and then do the work necessary to figure out what the possible values of that angle are, and then solve the resulting equations.